Take a good look at the slug. No, not that. That's a leaf. This slug. There we go. Elysia corlotica. May not look much. Okay, it looks like a bright green leaf, but it's one of the most extraordinary creatures around, living in salt marshes along the east coast of North America. It can go about a year without eating. During that time, it lives like a plant. Generally speaking, animals are what we call heterophobes, meaning they can't produce their own food. They are consumers of other life. Plants, meanwhile, are autotrophs, or producer. They can synthesize their own fuel from sunlight, CO2, and other organic compounds. Plants do this by using organelles called chloroplasts, which give them their bright colors and convert sunlight into food through photosynthesis. Elysia is what's called a mixtroph. It can both consume food like animal and produce its own through photosynthesis like plants. In fact, Elysia steals its ability to photosynthesize from the algae it eats by piercing the algal cells with specialized pointy teeth called radula. It sucks the cell empty and digests most of its contents, but the Elysia digestive system that balances throughout its flat body. This makes the slug look even more leaf-like, providing camouflage as well as food. As incredible as this adaptation is, there are more than 70 species of slug that steal chloroplasts from their food, what makes Elysia and a few closely related species in the Mediterranean and Pacific unique is how long they can hold onto their chloroplasts. Most of the slugs keep them for a few weeks at most, but longevity seems to be due to the survival ability of both plants and slugs. Said differently, the chloroplasts of certain algae can repair its own light-harvesting system, while most chloroplasts are thought to rely on their host cell and its genes for repairs. This makes the chloroplasts able to sustain themselves for longer inside the slug. Meanwhile, the slug adjusts its gene expression to improve its relationships with chloroplasts and remove damaged plasts to avoid accumulation of potentially damaging chemicals, though a few species can steal organisms from another species. So, these slugs are far from alone in getting an assistance from plant organizations as diverse as corals, giant clams, and sponges have the symbiotic algae that are living inside their cells, supplying them with organic compounds through photosynthesis. In turn, they supply their little helpers with shelter and inorganic compounds. Some of these mixtropes even transmit the algae to their offspring. Without the aid of these algae, filter-feeding corals, clams, and sponges would not gain enough nutrition in the nutrient-poor tropical ocean and dazzling coral reef they built simply would not exist. Mixtropes even cut both ways. An alga called Tripos fruca can consume several microscopic animals a day, allowing it to survive in the darkness for weeks. Tripos is in turn eaten by other mixtrope algae, providing frequent opportunity for exchange for organelles such as chloroplasts. They seem to allow some algae to the right parts of the dark ocean, such as the marine trench, which plants otherwise wouldn't be able to inhabit. The process by which Ella become a photosynthesized and triple switch between feeding models or method in what scientists believe led to the origin of all plants. Single-celled animals preyed on cyanobacteria. Some of these tiny plants were not digested and live on in the animal cells, eventually giving rise to chloroplasts. But these eukaryotic plants were soon consumed by other animals, which hijacked the precious chloroplasts, just like Elisa, and following example of eating and being eaten within the case of trios. This chloroplast haste happened to be 3 times giving rise to plastids with 4 membranes, and the ocean's most productive plants and forests.